Hi, it's Mr. Lowry. This is the Characteristics of Graphs worksheet. So this is a homework assignment that was assigned on 11/16 if you're in cohort A. If you're in cohort B, this would be assigned on 11/17 and just going to be due the next day. So I'm going to get you started on this one. There's 4 of these. I'm going to help you with a couple of them, and then you could do the rest of them. If you can do these on your own, I recommend that you try them. So if you're watching this video and you have no idea where to start, I'll get you started. If you feel like maybe you could do some of them, I would pause it here, do what you can, and I think you'll learn better that way. All right, I'm going to get you started here on this first one. A couple things to note here. First off, kind of hard to see, but this is an open dot right here. Then we got a line, and then we got a closed dot right here. Okay, so characteristics, another word for that is key features. So we're just trying to basically describe this graph in a few different ways. Let's start with the domain. The domain is all the possible inputs, or in this case, all the possible x values. So we want to look at our lowest x value and our highest x value. So it looks like we have -5 to 5. Our lowest x value is -5. Now actually that's kind of misleading because that's an open dot, right? And that open dot means it's not part of the graph. So what is our absolute lowest x value? Well, it's kind of hard to say. It's as close as you can get to -5. So -4.999999999 is kind of like our lowest x value. But we don't really say that because it's kind of hard to say in notation. So instead of saying -4.9999, we say, okay, -5 is like kind of the boundary. That's where my open dot is. But I'm going to put a parenthesis around it which says don't include -5, but go as close as possible to -5. Okay, now on the high end we have a closed dot. So this closed dot means we can include that 5. Okay, so a lot of times with the open dot you're going to use parentheses because you want to use that point as like a barrier, a boundary, but you don't want to touch that point, so you exclude it. With the closed dot, a lot of times you're going to use these guys for domain and range. Okay, another thing to note is that any part of the line is actually a closed dot. So this is part of the line, that's a closed dot, and this is a closed dot, and this is a closed dot. This whole line is made up of a ton of closed dots. So if you're looking for the lowest and the highest, this looks like the lowest and this looks like the highest, but those are closed dots. So my lowest value is like -4 and my highest value is 4. It's kind of hard to see, but these negatives, because they basically are right on top of the grid lines, but these are all negatives. We kind of know that already. So I go from -4 all the way up to 4. I start with my lowest y value, and then I end with my highest y value. In this case, we're going to use brackets because we're going to include that in our domain. We're going to include that in our domain. Or excuse me, our range. We're including those points. So everything on the line that's, doesn't look like an open circle, all these points we can assume are closed dots. Okay? Max is referring to the maximum y value. Okay, so that's a little bit tricky. So maximum graph, we're talking about y values, and we actually already have them. This is the max of your graph right here. This is the min of your graph right here. So max and min refer specifically to y value. If you remember on the diving exercise that we did, the maximum and the minimum, we were talking about heights. Max is right here. That's the maximum height of the diver. Minimum was down here. Minimum height of the diver. All right, discrete or continuous. So discrete means disconnected. Continuous means connected. So this is definitely a connected graph. Remember that a discrete graph is one of these graphs that has just like a bunch of points floating around, and it's not necessarily connected. So that's a discrete graph. It can have a pattern, right? So that's a discrete graph too. Discrete means disconnected, continuous means connected. So since all these, points are connected basically with the line, this is continuous. Okay, y-intercept. Where does it cross the y-axis? Basically right there, right at that point. So that point is 0, 0. Okay, x-intercepts. Where does it cross the x-axis? Here's the x-axis. So it kind of looks like there's 3 here, here, and here. But remember, this one's an open dot. And that open dot is basically saying that point actually is not part of the graph. It goes all the way up to that one, but then the open dot says, okay, no, it actually doesn't exist there. So that's not an x-intercept, even though it looks like there's a point there. It's an open dot, which means it's not included in the graph. This is our next guy here. So 0, 0 is definitely an x-intercept. And then here's our other guy. So sometimes we say that intercepts are 0 and 5, but these are coordinates. So when I write them, I want to write them as coordinates. The location of that point is 5, 0. The location of this point is 0, 0. Okay? All right, the next one's kind of funky. It's just practicing with function notation. So this is a regular 7, this is a multiply, and this is an f of 5. So this is just kind of, can you use function notation? Do you understand what it means? Let's look at this part for a second. Okay, f of 5. F of 5 means what's the height of the function when the input is 5. So if you look at your graph and you're like, okay, here's 5, input is 5, what's the output? It's 0 high. So an input of 5 gives you an output of 0. So this whole piece right here, f of 5, is just basically 0. So this is just asking you what 7 times 0 is. Kind of tricky, but it's just kind of, forcing you to use function notation. Okay, next is the intervals of increase and the intervals of decrease. So remember, these are pieces of the domain. They're sections of the domain. We're basically going to find like a mini domain. All right, now when we're talking about increasing, decreasing, we're talking about uphill or downhill. Okay, are we walking uphill or downhill? So if our guy is walking this path here, he's got to walk down, and then he's got to walk up the hill, and then he comes down the hill again. So from about here to about here, he's walking uphill. But from here to here, he's going downhill, and from here to here, he's going downhill. Okay, so the intervals of increase is from about, that looks to me like it's about -2.5 all the way to about 2.5. So basically, what times, like imagine this is a time, and this is, I don't know, height. Or basically, what time is he walking uphill? So from -2.5 all the way up to 2.5. Okay, now the tricky part here is even though these points are included in the graph, we're not actually increasing right at this point. When we get to the top of the hill, we're not going up anymore. We're not going down either yet. We're basically just at the top of the hill. At the bottom of the hill, it's the same thing. When we get down here, we're not increasing or decreasing at this point. We're just kind of hanging out. So the parts where it changes from uphill to downhill, that's neither increasing nor decreasing. So when we use our interval, we put parentheses around it because we're saying at that point, -2.5, even though it's part of the graph, we're not actually increasing there. And we're not actually increasing here. We're only increasing as we get, right up to it. Okay, for interval of decrease, we're walking here and here. So from -5 to -2.5, we're talking about what part of the domain. Now my domain starts here. Okay, so right here, I'm decreasing. And right here, we're decreasing. So we got a decrease, we got an increase, we got a decrease. And we don't care about height. We're not talking about how high did he go, how low did he go. We're only talking about the x values. When is he going up or down? Okay, so from -5 to -2.5, he's going down. That's part of it. But then over here, he's going down again. So from 2.5 to 5 about. Okay. Now again, we're not including that point. We're not decreasing here. We're not decreasing here. We're not decreasing here. We're not decreasing here. We're only decreasing in between. That's why we use these parentheses and not brackets. But even though these look like coordinates, they're not coordinates. This is not the point -5, -2.5. That'd be here. Notice that's not even on my graph. We're not talking about this coordinate. We're talking about an interval from -5 to -2.5. Okay. Since there's two intervals here, we're going to tie them together with this symbol, which is called the union symbol. It just means we're going to tie two intervals together. Okay, so that's some key features of the graph. Now, we didn't talk about positive or negative on this one, but we could have. We talked about increasing or decreasing. Not part of the question. However, if we wanted to talk about positive, negative, we'd basically be talking about above the water or below the water. Okay, so think about the x-axis as our water level. This is the interval where you're positive, above the water. This is the interval where you're negative, below the water. So just as, an extra help for you, if we wanted the interval where you're positive, it would be from 0 to 5. Okay, we're not positive at 0 because we're on the x-axis. We're neither positive nor negative. Right here, we're not positive or negative either. So this is an interval from 0 to 5, we're positive. Okay, the interval where you're negative is from -5 all the way up to 0, right? This whole section of the graph right here, we're below the x-axis, or like below the water, basically. So positive or negative is like above the water, below the water. Increasing, decreasing is like uphill, downhill. Okay, so this interval here is from -5 to 0, not including -5 or 0, because we're not below the water here, we're not below the water here, we're at the level of the water, but everything in between. Okay. So again, not part of the question, but definitely something that you can think about. All right, I'm going to let you do number 2. Now, when it gets to here, this kind of tricky part, just remember that f of 2 is a number and f of 9 is a number. So find out what f of 2 is, find out what f of 9 is, and then add them together. It's just practice with function notation. So this is, what is the output when the input is 2? So this is telling you the x value. You need to find how high it is. Okay, this is telling you the x value also. You need to find out how high it is. Once you have those two numbers, add them together. Okay, you got this guy on the back, same kind of idea. So we have, increasing, decreasing, x and y intercepts, domain and range, same kind of idea. So remember, for the increasing, decreasing, this is like uphill, downhill. When are you walking uphill? When are you walking downhill? Okay. And then the last guy here, this one's a little bit different. And the reason why it's different is because of the arrows. Okay. This arrow means that it keeps going up and up and up forever and ever. It also keeps going to the right forever. This means it's going down forever, and it's also going to the left forever. Okay. So I think actually I'll just go through this one with you because it's going to be really fast. Okay, the domain, what is the farthest left point? Well, it kind of looks like it's -6, but that arrow means it's going to keep going. So there actually isn't really a number that's the farthest left. So we're going to say -infinity. Okay, to the right, same thing. It kind of looks like we stop here at like 9, but this arrow indicates that we're going to keep going to the right forever. So there's no highest x value. Okay, the same is true for the range. This arrow means it's going to keep going down, so I can't find the lowest value. Can't find the highest value either. This arrow is going to keep going up. This arrow is going to keep going down. Okay, where is it increasing? Well, increasing again is like uphill, right? So when does this guy have to walk uphill? Basically always. He's always walking uphill. If you pick another spot back here, he only walks to the right. So as long as he's walking to the right, he's going to go uphill. So it's increasing from -infinity to infinity. Okay, it's never decreasing because this guy's never going to walk downhill. The only way he can walk downhill is if he walks backwards, and he doesn't walk backwards. He only walks to the right. Okay, so he's never going to be walking downhill. Okay, minimum is your lowest y value. Well, again, we already talked about it. There really is no lowest y value, so we're going to say -infinity. And maximum is the highest y value, right? There really isn't one here, so infinity. So lots of infinities on this one. Okay. So let's go back here and talk about minimum, maximum. So remember, the minimum is the lowest y. The maximum is the highest y. Okay, y-intercept is going to be a coordinate. Okay, so increasing and decreasing are going to be intervals. So make sure you write these in intervals. From here to here, from here to here. Okay, maximum and minimum are just going to be a number. Y and x-intercept are going to be coordinates. Okay, so let me help you out. Domain is going to be an interval. Range is going to be an interval. Increasing is going to be an interval. Decreasing is going to be an interval. Maximum is going to be a number. It's a y value. Minimum is going to be a number. So is maximum. They're both just y values. So number, number. This is going to be a point. So you should have an x and a y, and x-intercept is going to be a point, if there is one. So look at that for a second. Think if you can see where it crosses the x-axis. Okay. Again, increasing, decreasing, that's going to be an interval. Where is it going? Uphill. Where is it going? Downhill. Okay, max and min are just a number. These are going to be intervals. So domain is an interval. Range is an interval. Max and min are just numbers. Your highest y value, your lowest y value. Interval of increase, obviously this is an interval. It's where you're going uphill. Okay, interval is decrease. Okay, that's obviously an interval again when you're going downhill. And then function notation practice. So that should, get you started. That's a pretty good chunk of it. You just got to kind of fill in the other two. And we'll talk a little bit more about key features next time in class and talk about interpreting graphs some more as well.